a lot of the things that we're going to interact with from here and out is just more complicated arrangements of the things we've learned so far. And we get to say words we know, except we put a little bit of spin on them when they become parts of compounds. Like we did with the first group of things we did something called an alkane. And when you put them on front of a group, you called it an alkyl group. Or like we had methane, we turned it into a methyl group. We had an ethane, we turned it into an ethyl group, and so on. They're very similar, and so we get to use a lot of the same words over and over and over again. So we're going to introduce what a halide is, and it's basically a halogen. You remember the halogens from, I don't know, whatever, grade 9, you learned about all the different groups in the periodic table. Halogens are all in group 17. And they all can be included into alkane structures. They form a single bond because all of our halogens are in column 17, which all have a single negative charge. They're one electron away from being full, so they like those single bonds. And they replace a hydrogen along the chain. So you can basically replace any of the hydrogens in a alkane chain with any halogen. You can add many of them, so multiple halogens can be added to the alkane. You can fill it as full as possible. Let me just slide that to where it looks nice there. We still follow the alphabetical order rule. And so that allows us to put the words in the right order. We use the prefixes that we did for multiple groups. Our di, tri, tetra, penta, hepta, and so on. All those. Remember, that's 2, 3, 4, 5, 6, 7, and more. And so our prefixes that we're going to use are halo prefixes. I love how we get to use basically the same word over and over again. Halogen, halo, halide. It's all basically the same word. It's just like doing verb tense on it. We have our fluoro group for fluoride or fluorine, the chloro group, bromo group, and the iodo group. So yeah, that's for iodine, iodo group. That will get into some weird words, but we'll draw some branching alkanes here and replace some of these words with some halogens. So we still follow all the same rules of naming that we did in the last lesson. We start with a long parent chain and then replace hydrogens as necessary. So what is my parent here? It's a heptane, so we're going to have a 7-carbon chain. And we're going to have a whole bunch of different groups on it. So I'm going to start by drawing my 7 chain here. 7, 1, 2, 3, 4, 5, 6, 7. And I'll just start numbering it from the left because that makes it easy. I get to put them wherever I want. I might as well go left to right like our normal numbering system works. All right, so the first one I got to put down here is I've got one bromo group here. So on the very first carbon, we can add a bromine here. So the very first carbon, I'm going to throw a bromine on here. And it can be on first because it doesn't extend the chain because it's not a carbon. So it wouldn't make the chain any bigger. It's not a part of the chain. They're just replacing one of the H's. I have, let's just do that. That's the bromo group. I highlighted in green. Let's keep it with the green. We can do, let's change this to that. Okay. The next one is I'm going to see this 3,4-dichloro chunk. So that's 2 chlorines on carbons 3 and 4. So we get a chlorine here and a chlorine here. I don't know why I put them on opposite sides. Doesn't actually matter. Let's finish circling them in the right colors. And then we have our next group here, a 3-methyl group, so a single carbon group on carbon 3. So we put a carbon group there, and that'll do it. So that's my carbon group there. And now I will just add my dashes to fill out the rest of this compound. All right, I got all the extra dashes laid out for all the extra hydrogens that will be there. Again, we don't want to put those H's down. Even adding all the dashes there felt like a lot of extra work for no reason. All right, let's look at the naming of this one. We have so many halides here. Look at this ridiculous thing. Now, which one is going to come first in my list? Am I going to add the chlorines or the fluorines in my name first? I'm not going to add fluorine first, because chlorine starts with a C, and fluorine starts with an F. C is first, so we're going to do the chlorines first. So this will indicate what numbers I want to use. So I'm going to use the ones down by the chlorine. So I'm going to number them starting down here and going up here, because the centers are my carbons. So that'll put my number ones first. It's not terribly bad because I think it'll work out the same. They'll be the same numbers of each numbering system. It doesn't really matter, but generally this will look better. So chlorines are first. How many chlorines? 2 chlorines. So 2 chlorines on, where are they at? Both on 1. So both chlorines on there. So I'll just do 1, 1. I'll just say that there. I'm just doing a list so I can write it out later. It's a very long name, so I'm going to do all of my notes like on the top and then write the name on the bottom here. The next one, how many fluorines do I have? 6 fluorines on 1, 2, 2, 3, 3, 3 is ridiculous. And what's my base carbon chain? Yeah, 3 carbons. So this is a fun thing. So, and we're going to do it in this order. We're going to have 2 chlorines on 1 and 1, 6 fluorines on 1, 2, 2, 3, 3, 3, and then 3 carbons to finish off my name. So 2 chlorines is going to be dichloro. So we start our name with 1, 1, dichloro. So that's the first chunk of the name. So 1, 1, dichloro. 2 chlorines on carbon 1. And then I will write all the other ones. 6 fluorines on 1, 2. I don't want to put the comma there. That's wrong. I'm just going to erase that little bit there. I can put this in there. That's fine. That's how I will put the difference. So 1, 2, 2, 3, 3, 3. Hexafluoropropane. Got it. So it was a lot going on there. It was a heck of a lot of numbers. The halides will come with a lot of numbers because you got to tell them where they are. So a lot of numbers come out of that. So hexafluoro. Remember, it's fluoro, not fluoro, so the U comes first. So if you ever write fluoro, you're like, oops, no, it's not fluoro, it's fluoro. Remembering that when pronouncing the weird double letters is we use the regular prefix sounds. So the 2, 3 next word is we have these doubles in here. So we don't go triodo, we go tri-iodo. And instead of going ductane there, it's iodo-octane. So we break our syllables where all the prefixes go. So we break our prefix sound here, and we break our prefix sound here. Tri, iodo, octane. So when we're saying it out loud, we don't say it weirdly. We split our saying it where the prefixes are. So carbon is another one of those, another way carbon is awesome is it doesn't just form single bonds. It can form double and triple bonds. No four bonds, just doubles and triples. So singles, doubles, and triples is it. There's no four bond. That would be ridiculous. So it can form, oops, not that color, undo. 4 bonds total, but it can be multiples. A carbon that forms a double bond is called an alkene. So it's basically an alkane, but we put an E in it instead. And to be even more annoying, when we get triple bonds in them, they become alkynes with a Y. So basically, all that's different is we have this like letters in the middle here that we're messing with. That's it. Both of them can be in the middle, at the end, anywhere along a common chain. If we throw a single double bond in there, it becomes an alkene. If we throw a triple bond in there, it becomes an alkyne. And we have, I think I'm going to be nice to you and not put both in, because naming both sucks. It stops making any sense. It works, but it's even more obtuse. So I think I don't do that to you. Double checking. All right. So basically, when we name it, we're going to put an ane ending into an ene. Oops, that was still highlighter. An ene ending, and triple bonds go to ine endings, and we use a number to indicate the lower numbered carbon involved, and the number goes in front of the name of the parent chain. I'll show you one of the alternatives, and it sucks. I like this way better. The number of the parent hydrocarbon to give the multiple bond the lowest possible number. So when we have these multiple carbon bonds, this is now taking the priority. So you're going to do your numbering based on the double bond or the triple bond, and then everything else will come as it goes. So wherever the double bond is, that's where we're trying to make that number the lowest. That will create the priority. I'm going to add different names of different groups. We're going to add into those, and they're going to take priority. But so far right now, the double bond or triple bond is going to be the highest priority when numbering. All right, so we're going to try to write the structure for the different forms of hexene. So hexene is going to have a double bond in it. So where can we put the double bonds? We can put it almost anywhere. And so we're going to figure out how many are going to be isomers, right? How many are going to be different and not just repeats of the same thing. So let's put it at the beginning. So if I put a carbon here with 2 hydrogens, a double bond, and then a carbon with 1 hydrogen. Notice I'm doing our condensed structures. This is another practice of the other kind of structures. So I'm doing it with just the letters, because that will also save us a little space. So now I've put this in here, and then I can kind of follow the pattern as we normally do with CH2s. I just need to get to the total. So 3 more. 1 more of those. 1, 2, 3, 4. 1 more. CH2. And then a CH3. Okay, 1, 2, 3, 4, 5, 6. Good. I got 6 total carbons. And so this double bond is attached to this carbon, right? The double bond is on this carbon and this carbon, right? The double bond is between these 2 carbons. And so what number should I give this particular hexene? I'm going to give it 1. It's going to be the number 1 because it's the lower of those 2 numbers. So I'm going to write this as the name is 1-hexene. So that's the name of this particular thing. So we're going to do the same thing, but we're going to shift the double bond down one piece in the chain. So now we're going to take the CH3, then we'll go CH, double bond, CH, then CH2, CH2, and CH3. I think I got that there. So now my double bond is the lowest on that side. That's carbon 2. This is 2-hexene. Is there another one that's not a copy? Can I do 3? It's not a copy of one of the other ones? Yes, I can. So 3 is the next one. Notice the spacing I gave it. There's that space for the third one. Oops. Go away. So we're going to have CH3, CH2 dash, CH double dash, CH dash, CH2, CH3, and we will get 3-hexene. Yeah. And that's going to represent this carbon. Doesn't really matter on which side each of those are. But can I do a 4-hexene? No, a 4-hexene will be basically exactly the same as 2-hexene. So there's no such thing as a 4-hexene. There is a way of writing this that you may see depending on where I steal different worksheets from. That may be written as, I've seen it this way, hex 1-ene. I've seen that, and I hate it. So I like the other way better. I've seen both being true, but I've seen that. That is useful when you have more than 1 enes, which is awful. Yeah. Yeah, so generally we don't do that, but it might show up in a question somewhere. But I would advise against it, especially if there's only one. If there's multiple double bonds in something, this tends to make more sense, but we're going to leave that just the way it is. Let's do the butynes. Good news, butine is only 4 carbons, so it's doesn't have that many options. So before drawing our H's in, I'm just going to give a lot of space so I can fit the H's in after. We can put the triple bond on the first carbon. Leave a space, 1, 2, 3, and then get a carbon, and then I'm going to put the rest in here, CH2, CH3. Now, I'm leaving the space here to try to get how many hydrogens each chunk will need. How many hydrogens do I need for this very first carbon? I need 1 more hydrogen. This carbon sees these 3 bonds, and so it's missing one, so it needs 1 more hydrogen. So in this case, we have to write an H here. So it's CH, triple bond, C, and then how many hydrogens do I need for this gap? I need none, right? So there's no hydrogens in this gap at all because this particular carbon has 1, 2, 3, 4 bonds attached to it. It's already full. There's no hydrogens at that center. Does that make some sense at least? It's not a great diagram for this. It'll make more sense when we do the other side of the page, hopefully. So we're going to do the triple bond in the only other place that's left, which is in the middle. There's only one more. So I'm going to write CH3-C triple bond to C-CH3. So that's the other form of butane. Am I missing any hydrogens in this particular example? No, there are no more hydrogens. I covered them. Yes, Bob. What are triple bonds used for? To this, we got to name these things. What's the name of this particular butane? What number should it get? Number 1. It's 1 butane, and the other one is 2. 2 butane. Feel like the count sometimes. So 1 butane and 2 butane. And to do a little bit of labeling here, this 1 means this 1, this 2 means this 2. Another way to double check you have the right number of hydrogens is both of these compounds have exactly the same number of hydrogens. They both have 1, 2, 3, 4, 5, 6. So they have 6 hydrogens total in this particular compound. And this is 3 and 3, 6, 6 and 6. They're the same. Because these are just isomers of each other. So we're looking at a butene. So, right, the butene, that's our double bond. I don't know, can you see that? It's pretty green, but it's not bad. So the ene is going to give me a double bond. So between carbons 1 and 2 is going to be a double bond. So I'm just going to draw the carbons first. Double bond with a carbon. I'm not going to do, let me just take this a moment here. I'm not doing condensed. I'm just going to do structural. The bigger kind. Just leave the structure off. Erase. Just leave it. Yeah. Just not condensed. I'm not going to do the condensed kind. I'm going to do the bigger kind. Because it makes more sense. Hopefully it'll make sense. And then let's put out my base here. So this is a butene. So it's going to have 4 carbons here. So this is my 1 butene done here. Then I have to add my methyl group. Where's the methyl group going to go? It's going to go on 2, so it's going to go in here. So I'm just going to put it down because this is where I've got my particular arrangement. So I have to add in this particular diagram extra my hydrogens at least as like dashes, right? So the right side is exactly the way you would expect, nothing different there. But there's nothing going on up here because carbon already has all 4 bonds labeled here. I've got 1, 2, 3, 4. This carbon is full. How many is missing off the end here? 2. And I'll show you where they are. We'll get to this later. But they don't go up and down. They kind of become this like kind of triangle-y pattern. So just up and down isn't wrong, but it's more accurate to be a little bit more triangular there. So this will tell us still the total number of hydrogens we need. Oops, I didn't do the end of my methyl group. Now we're good. So I've got my butene here. That's my butene here. And my methyl group is this one. So 2 methyl group goes there. So now I've added all my fancy highlighting. Let's go into the next thing. We have a pentyne. So my triple here, let's just put this here. Triple off the first one. So I'm going to just do very similar. 1 triple bond there, and then fill in the rest like it's an alkane. 1, 2, 3, 4, 5. Got it. So that's our 5 there. Let's see what else we got to put in here. I've got to get 4,4 dimethyl. So I've got a methyl here and here. So my dimethyls here, both on 4. And add hydrogens. Add the hydrogens here. Add my hydrogens there. That's not great for the picture. That one can have some. And then you have to just double check that all the carbons have 4. Does this carbon get any more? No more for this carbon. What about the first carbon? It gets 1 more. And just for clarity, it goes straight out. Just does. We won't get into the reasons for that. It has to do with electron negativity and so on, but we won't get into why they're that shape. They just are. So the downside is I have to just tell you this is the way it is and not why for everything. All right, so 2 more names, and we have to do the same strategies that we do before. We figure out the parent chain and then what's stuck to it. So my parent chain here, just got to count the bottom here. 1, 2, 3, 4, 5, 6, 7. We have a heptene number here. So we're going to have a 7 carbons, double at, what number should I give my double? It should be the number 3. So the double's at 3, basically 1, 2, 3 is basically going to be where my numbers are set at. So my numbers are going to be 1, 2, 3, 4, 5, 6, 7. That's where my numbers are going to be. What else is happening in this particular molecule? I have a methyl at 2. So I have dimethyl. Oops, let's not write that way. I want to go. Oops. 2 methyl at 2 and 4. So we've got 2 methyls at 2 and 4, a double bond at 3, and 7 carbons total. So to put it all together, we're going to get 2, 4 dimethyl, 3 heptene. So hopefully that makes our sense here. We'll put the 3 there because the double bond can move. There's not one place for it to be.
You missed an L.
Where? Oh, methyl. There. Good. Thank you. Found it. Dimethyl, not dimethy. Good. Excellent. Let's try the other one. What's my base change? Okay, we're going to do our chain length first. 1, 2, 3, 4, 5. So we're going to have a 5 carbon chain. Draw. So 5 carbons. Triple at 2. So the triple's at 2 in this case, because that takes our priority. We also have 2 bromo groups, bromine, at 1, I guess. So both at 1. 2 bromine at 1. So thankfully there's only 1 functional group and a triple bond, so we don't have to worry about which order they go in, because bromine's going to be first in most cases because it's B. There's not many A groups. So to write out my name, I'm going to have 1, 1 dibromo, 2 pentine.